let's start off with a few practice. Would be another fun one. Let's see. So you guys, I want you, those of you who are awake in here, go ahead and put the answers for these in chat. So for the first three there, give me a name for those compounds, and then I'm gonna, in addition to the copper 2 acid, I'm gonna put maybe another one. For that one, give me the formula. Okay. That would be a fun one. So when you have them, go ahead and put it in there, and we'll see if you're on the right track. So remember, all of these are going to be ionic compounds, which means they are just the names of their respective ions put together. And so what you need to do here is identify the ions, know their names, and then you can put them together to form the compound. Oh dear. Yes, you certainly should have. So in that case, what you might want to do is, instead of watching this one right now, you may want to just spend this hour looking at the one from Monday or yesterday, because we're just going to keep on doing more naming. And so if that's something that is completely foreign to you, you will probably fall behind. So let's hope that doesn't happen. Wow, there are only 3 of you today. Wow. Okay, fine. I guess I have to do everything. Okay. Cool. So, barium, as we know, in ionic compounds always has, yeah, good idea. I already have fun. Barium always has a 2+ charge, right, in ions. And so we know that the hydrogen in this case is -1. We know that this is called a barium ion. And remember, when hydrogen is negative, we do have, I am going to be streaming tomorrow. So if you do end up watching all of the videos from Monday and Tuesday and then today's, then come back tomorrow. Otherwise, you'll just have another one to watch later on. Just so you know. Right, this is the hydride ion, right? Remember, negative simple ions have that "ide" ending. Alrighty, next one. Yeah, that looks great. Hooray! Thank you, Lamonda. So Lamonda has figured out, we of course have Cl- in here, which tells us that our cobalt is 3+, and so remembering that transition metals, we have to put the charge in the parentheses there, would be the correct way to name these. Very nice. Last one is a little easier one again. We have I minus and Na plus. That's just going to be sodium iodide. Don't forget the ending there. We've got to make it "ide." So iodide. Alrighty, so going from name to formula, I think is a little bit easier, specifically because the transition metals charges are already given to us, so we don't have to think about them. So all we have to do is charge balance our compounds. So copper 2 tells us we have Cu2 plus, and we have acetate, which we'll find on our table of polyatomic ions. We can see here that we're going to need 2 acetates to balance out the copper. And so we would put them together like that. So it looks like the next one has 3 names. But something to remember is that some of our polyatomic ions include the word hydrogen in them. So the potassium, of course, is always just going to be by itself. If we try and look at this one, we're going to see, oh, that is one of our polyatomic ions, which is HSO3 -1. And if we see they have +1 charge, -1 charge, so we just gotta put those guys together. What the heck just happened? Oh dear. Okay, well, I'll just write it again. Hooray! What? Okay, I must have like clicked something rather awful. Excuse me. Damn the smoke! Okay, one of these. Aha! It must be this button here. No, not that one. It's not you. It's not the erase button. No, it's not that one. No. Well, I don't know, maybe, what the heck, I can't even get rid of it. Bleh. There, problem solved. Yeah, thank you. Yeah, it's unfortunate. The smoke always, every night, it just freaking comes back. And it's like, you know, oh goodness, hold on. Maybe, nope. Yes. The worst is when you can't sneeze, you know? It's like right there, but not gonna happen. Okay, well, anyways, do we have any questions on any of these 5? And if there are no questions, would you like to do a few more examples before we talk about our next one? Or next, like, kind of class of naming? This morning I did put up your homework, by the way. It's about like 150 problems like this. How exciting. So, okay, you want to do a few more? Okay, sure. So yeah, there will be plenty of practice for you guys. And I guess while you guys are working on these, I can go take some allergy meds. Yay! much as I love squirting things up my nose, those just make such a difference. Okay, let's see. How about we do that one there and just note this one right here is tricky. The very last one there. So go ahead and work on these for a sec. I'm gonna go like blow my nose or something, and we'll see if I survive. Okay, so go ahead and work on these. Once you have your... Oh, come on, really? No, yes, I don't know. Okay, once you have your answers, of course, just write them in, and we'll have a look. Okay, any ideas? So just so you all know, this process does get a lot faster for you over time. Because right now we're not only like learning where things are on the periodic table, so like half your time is spent where the heck even is tin on the periodic table, you know? Just learning the symbols, that's definitely part of it. But also the polyatomic ions. Yeah, all this stuff will take time when we're starting it, but you'll see you'll get pretty fast at doing these. So that 150 problems of fun is for that purpose. It's going to help you to recognize the elements more quickly and your polyatomic ions as well. Okay, so tin, I will tell you, is Sn. It's one of the elements that has a different name than its symbol because it came from like a Latin root. And so what charge is the tin gonna have? Or do you guys want a few more minutes to just like work on the rest of them? I don't want to like rush you or anything. So since we are doing tomorrow too, we have a bit more time, so we can slow down here as necessary. All right, so, okay, let's get to it then. So, the tin there that we've drawn, Sn, we know it has a charge of 4 plus, because that is the number that was given to us, because this is it's not a transition metal technically, but it is what's called a poor metal. It is a metal that has a variable charge. And you'll see it's in the p block, you know, way kind of out in the middle. Its atomic number is 50. So you'll see it there if you can't find it. And then, of course, bromide is Br negative. Remember that ide ending is going to be for... There are a few polyatomic ions that end in ide, but by and large, ide is reserved for single elements that are negatively charged. And so putting these together, we're going to need 4 bromides to balance out the tin, and there we have it. Same thing here. We've been given titanium 4 plus as our metal, our positive ion here. And this time we have bromite. And just so you know, anytime you see an ite or an ate ending, that's going to tell you that it's a polyatomic ion. Only polyatomic ions have such endings. And so we're going to have to look on our fancy little table there, and we're going to see bromite is BrO2 negative 1. And so we see here, okay, so we're going to need 4 bromites to balance out our titanium. And so we are going to have to combine them together in this way. Don't forget your parentheses. We have to indicate there are 4 of that polyatomic ion in there to balance out the 1 titanium ion. It's funny, I keep trying to hop between Ridgecrest and LA, trying to avoid the smoke, but it just never works. Bleh. Okay. Any questions on those two? If not, we can look at the next one. Interestingly, there are technically 2 possibilities for the next one. So this is somewhat of a vague one, but we can approach it 2 ways. So it's interesting. Okay, so in that case, let's go ahead and take a look. We can do our... So we have manganese in this, right? Manganese is a transition metal that has variable charge. So we will need to figure it out before we can give it its name. So we could do a couple things here. We could crisscross, or we can just kind of do the algebra. I like to do the algebra, but you are welcome to crisscross. Just so you know, this one will require a double checking when you crisscross. So manganese plus 2 oxygens equals 0. Manganese plus 2 times negative 2 is 0. Manganese minus 4 equals 0. So manganese is plus 4. And so we can write this as manganese 4 oxide. So that is, I would say, 99% of the time this actually 99.9% of the time this formula is referring to this name, manganese 4 oxide. However, technically, I'll do it in green. This one could be peroxide. So remember, peroxide is one of our polyatomic ions, and if that's the case, then this would have to be 2 plus to balance out the 2 minus from peroxide, and so this could be manganese 2 peroxide. That's probably not the case because peroxides are not very stable. And so it's unlikely to be this, but technically from this formula, you could get either of those names, depending on which one that O2 represents. And so, just so you know, I'm not going to give you something like this on an exam, of course. That would be just mean, be like, haha, you'd have to guess it's the peroxide or something. No. I will ensure that everything on an exam for you guys will just have one option. Unless it's something like bicarbonate versus hydrogen carbonate, since it's multiple choice, like I'm not going to give both of them as possibilities. So I will, of course, be fair. So just so you know, there is a couple, or I think there's maybe one of them on the homework that is like this. That's going to ask you for two possibilities. So this could be something that you might see on the homework. Okay, so that one was tricky. Do we have any questions on that one? Sorry for just going up and down there. Okay, I'm not seeing any questions, so next one, let's crisscross it, because why not? Double check. Is phosphate with its correct charge? It is. Phosphate should be -3, so we're okay there. And so we just need to give it the proper name. So iron, again, transition metal. Perfect. Lamondo's got it. Iron to phosphate. Let me just draw a line here just so we don't get those confused. Alrighty. Let's approach our last one now. Tricky, tricky, tricky. One thing we notice right away from the next one is we have two of these guys, right? And so what gives there? Remember, I'm only going to give you correct chemical formulas, I'm going to give you correct chemical formulas. So if I give this to you, you can't say, well, hey, you forgot to reduce them. That is intentional. What I'm telling you here is that these come from different sources. So this one is a subscript from balancing. This one is a subscript from a polyatomic ion. And how do we know that? Well, if we look at the nitrate part, the nitrate already has its subscript from being polyatomic, right? That's that 3, the NO3. And so, because that 2 there is outside the parentheses, that has to be a subscript from charge balancing. And so, because these are both the same, that tells you that the other subscript is not from balancing. And if it's not from balancing, it must be from a polyatomic ion. And so we have to think, what the heck, is there an Hg2 polyatomic ion? And yes, there is. Hg2 2+ is mercury 1. Which I understand looks confusing because it's like, what the heck, we just did all these transition metals that have the same idea. But mercury 1 is a very special case. It always occurs as like a pair. So you have to have an even number of mercury 1 ions, just the way it is. And of course, we know that this guy is nitrate. So your name for this one will be mercury 1 nitrate. So to do this one, okay, I can get it all, yeah. We have to understand that the mercury there is a polyatomic ion. And so mercury is the only metal that does this weird thing, so maybe just keep your eyes open. If you see mercury, that's a possibility that it might be a polyatomic ion. So there will probably be some evidence of that if it is a polyatomic ion. So try and keep your eyes open for that. So that one was extra tricky. And so, again, with these, we see that sometimes things might look very similar, but this one would be mercury, mercury 2 nitrate. So, again, these will look similar to each other in terms of their formulas, but they are different things, right? The other one had 2 mercury ions, and so that was mercury 1 nitrate. This one is mercury 2 nitrate. Okay, mercury 2 is not a polyatomic ion. It's just plain old regular mercury like this. This one is the polyatomic ion, and so we have to have a sad face here. So they look super similar. It's kind of just like oxide versus peroxide. It's similar. So mercury does something just like oxygen here. Though oxygen is also weird. You don't need to know this, but I'll tell you also has a third one, which is just awful. And this one is called superoxide. This one is peroxide, and this one is just regular oxide, right? So superoxide exists too. The point here is just be careful. Sometimes polyatomic ions can sneak up on you. So for mercury and oxygen, you might want to just keep your brain open to potential for polyatomic ions there. I'm not going to give you anything with superoxide because that would just be mean, but it does exist. So that would be another one. Okay. Fun stuff. If there are any questions on those, I'm happy to take them as I start writing the next part. Okay, so ionic compounds tend to form crystals where they kind of alternate positive, negative, and they just make big old crystals. Sometimes water kind of gets trapped inside of it, and it actually becomes a component of that crystal structure. And we call these hydrates. And we have an easy way to talk about them. Oh my goodness, not boron. So how we understand a hydrate is a hydrate would always have this part. And so it's telling us that for every kind of unit of BaOH2 that we have 8 water molecules that are kind of stuck around it. and they are forming a part of the crystal structure. And so this is called a hydrate. And so, in order to name a hydrate, it's just the ionic compound name. And then you just stick on another word that's going to have hydrate at the end. Here, in dark blue, the things that could go in this blank would be some prefixes. Hepta and octa, yeah. Here, I'll just go up to 10. So you'll have some prefixes to tell you how many waters are stuck onto your compound. And so in this case, that first thing is barium hydroxide, right? Hydroxide being the polyatomic ion, barium being our positive one, and we would call this octahydrate to let us know there are 8 waters that are stuck on this barium hydroxide. So it's just a matter of using the right prefix to indicate how many you have. So we can do this one, and let's do these two. So, in order to name hydrates, all we have to do is name the ionic compound and then put the prefix for how many waters there are. And so with this compound is sodium acetate. We know that because this was those 2 ions. And we have to put monohydrate. 1 water is a component of this particular compound. Another one, this cobalt 2. We have sulfate. They have the same charge but opposite, so we can just stick them together. We have a hydrate, so we're going to put this little dot there. It says heptahydrate, which is going to be 7. And so our formula would be COSO4 dot 7H2O. The dot is not like a period, it's kind of like in the middle. So like a multiplication dot in mathematics. Just so we know, I guess I should have put the Arabic numbers in case we have forgotten. So those would be part of it. Okay, one thing to note on hydrates. We are going to include the waters in our molar masses. So if you were calculating the molar mass of the cobalt sulfate heptahydrate, you would include the waters there. In fact, let's see. Okay. So let's see. I'll prove it to you. You think I'm crazy? Well, I am. I'll prove it to you in other ways. Go to Wikipedia, cobalt sulfate. I guess I should have put 2. Okay, it did it for me. Aha! So, if we look here, look at these molar masses that are given to us on the Wikipedia page. We see here that we have a molar mass for anhydrous, that means no waters on it, one for the monohydrate, another one for the hexahydrate, and another one for the heptahydrate. Remembering that water is about 18 grams per mole, you can see that difference here between like just adding these waters on. And so that's what, so it's important that we remember that because these are kind of like physical structures, we want to include our waters for any molar mass calculations we do anytime we see hydrates. Okay? We will see later in chemical reactions in chapter 9 I'm just going to put this out here, but we're going to talk about this later. Most reactions that we're going to do in this class or 111 or 113 are going to be done in water. And so as soon as you dissolve these compounds in water, those other waters just join the other waters. They are no longer attached to the compounds. So anytime you see a hydrate, that has to be a solid. And so as soon as you dissolve it, that water goes away. And so it's not going to be part of a chemical reaction. And that is something we're going to see many chapters from now, but I just want to kind of plant that idea in your head. Okay. One last thing. Oh, goodness gracious. Hydrates are the only time you use a prefix with ionic compounds. We're going to see what that means in just a second. But the most common error that students make when naming ionic compounds is we've just spent, a day and a half talking about how to name these things, right? Students will just throw it right out the window when we go to our next group of how to name things, which we're going to see right now. We're going to talk about covalent compounds. These do not have, they're not charged. So they're not made of ions. And they will only be made of nonmetals. So here is an example of a covalent compound with which we are familiar. And here's another one, which we are presumably also familiar. Here are the names of those. Both compounds you've heard about before. We're going to see that covalent compounds are actually very easy to name. All we do is put the names of the elements and how many we have per molecule. So previously, I will do it in purple. If we think about potassium this can only make K2S. However, we're going to see that we can make all sorts of different compounds with nonmetals only. So for example, all of these are possible sulfur and oxygen combinations. In ionic compounds, they only make one thing. If you put potassium and sulfur together, they will make potassium sulfide, and that's it. However, if you put sulfur with other nonmetals, we're going to see a whole bunch of different compounds are possible. And so we have a different way of naming them. And I'll tell you the names here, and then we'll talk about the rules. Sulfur dioxide, sulfur trioxide, disulfur trioxide, disulfur tetroxide. So, with covalent compounds, that is, there is no metal there, only nonmetals, we're going to use the prefixes. The same prefixes we talked about with those hydrates. These ones here. The mono, di, tri, tetra, penta, hepta, all that stuff. These ones here. Okay? So, most of these you'll probably remember from like geometry, like pentagons and hexagons and octagons and all that stuff. So hopefully those are somewhere in your brain. But that's what we're going to use here. So how we name these things is we put the number of the first nonmetal. Why did I put an underline? And then the number of the second nonmetal. And then we do it with the "-ide ending. And so the number we'll put is going to be one of those prefixes, like mono, di, tri, etc. There are two things we just have to keep in mind. Never start a name with mono, and we drop the A before oxide in a prefix. So that means something like, I don't know, not carbon. Let's do, I'm just making up this thing. So we would call this penta nitrogen octoxide. We don't say octaoxide. We drop the A before oxide if there's a prefix. Or if we have, here's another one. Diphosphorus pentoxide. So notice again, we dropped the A from penta. Penta was our prefix. We drop the A before oxide. So those are the only like kind of two special rules that we have to keep in mind for covalent compounds. Otherwise, they're easy. You just say how many of each one they are in the order that you're given. That's it. So practice time. So looking at these, again, it's just a matter of knowing what the symbols mean and then learning those prefixes. So this one is going to be phosphorus pentachloride. Pentachloride. So end with the "ide." We never start with mono either. So we do not say monophosphorus pentachloride. We just say phosphorus pentachloride. This one, phosphorus tribromide. Nitrogen monoxide. So why don't you guys do the next three rather, because I know how to count, keeping these in mind. Just so you know, 6 is hexa, and 4 is tetra, and 10 is deca. And go ahead and write them in as soon as you've got one of the names. Absolutely. Sulfur. Hexafluoride. Very nice. This next one is one of the rare examples in which you'll have a noble gas as part of a compound. And you're absolutely right, Sherry. Very nice. So, in my opinion, these are the easiest ones to name because it's just how many of them are there? Boom, done. No worrying about charges, trying to figure out is that iron 3 or iron 2. None of that stuff. No polyatomic ions to memorize. It's all just numbers and names. This one would be tetraphosphorus decoxide. Beautiful. One thing, Lamonda, we're going to drop that A before oxide. So decoxide. Yep. Perfect. Yep. Very nice. So we can also go the other way around. I don't know. Or let's see, what's another one that we can do? It's hard to think of these because there's, I just have to think of numbers and stuff. Okay. So going from name to formula is, I think, the easiest one of all. You just have to put the compounds there with the correct number of them. That's it. So, yep, beautiful. And so looking at the next one, we see tetraboron. That tells us B4. And then heptoxide tells us O7. And that's all there is to it. So, um, while I wanted to start naming our final group today, what I'm going to do instead, we're going to take it slowly, and I'm going to just give you more problems to do. Because why not? Let's see. But this time, what I'm going to do is I'm going to now include ionic compounds. So, or these ones I just gave you all covalent compounds. Now I'm going to give you a mix. So it's up to you to determine if it's an ionic compound or a covalent compound. How do we know this? Covalent compounds never have metals in them. Nothing positive. No charges whatsoever. So no metals. If it's non-metal only, it's a covalent compound. You use the rules with these prefixes. If it's an ionic compound, we use the same rules that we learned yesterday. Okay? So, let's do a couple of examples. What would be something fun to put with selenium? Let's make that 4 instead. Yeah, let's do that. Alright, practice time. Have fun. Give me some names. So first step for naming always is to identify, is it an ionic compound or a covalent compound? And from that you have different rules for naming. And just so we know, again, necessarily, all these rules are right here. So far we have gone through these rules. So we've talked about ionic compounds. Remember, that's when a metal is present. You're going to have an ionic compound. It's made of charges. And then you have covalent compounds, which are nonmetals only. One thing to note about ionic compounds, a metal is present is like, again, 99.9% of the time, but sometimes you could have these positive polyatomic ions. Like ammonium nitrate technically does not have a metal in it, but it is an ionic compound. Okay. So it is up to Lamonda and Sherry to come up with the answers for these. Yep. Practice makes perfect, right? Very nice. I'm extra proud of that first one because oftentimes when I start mixing them up like this, some students will say, oh, well, that's calcium difluoride. And I say, no, no, no. And bust out the red pen and, angry stuff. So, yay! You did not put the dye in there. That is beautiful. However, you have also noticed that we do need the dye for the next one because that is a covalent compound. So just so we know, that's a metal. And there are no metals here in the second one. And so, therefore, this is ionic. This one is going to be covalent. And so, on your homework, by the way, which is just a bunch of naming problems, it may help you to, before you even start naming them, just go over every single one and say, okay, is this an ionic compound or a covalent compound? And just maybe like mark a little I versus or a C or something, just so you'll remember when you go to name them, okay, this one's ionic, I have to follow the ionic rules. Or, okay, this one's covalent, I have to follow the covalent rules. Or, as we'll see tomorrow, this one's an acid, and I will have to follow the acid rules. Okay, anyways, off my soapbox there. We just have a few minutes, so I'm going to finish the rest of these for you guys. I would have liked to... Oh, we've got Sherry, kind of. Potassium never needs a Roman numeral. Right? Potassium is always K+. And that 2 that you see there is actually from the dichromate, because dichromate is 2-, and so that's where this guy is actually from. That's the 2- that came from before. So potassium is in fact just +1 charge there. So this one is going to be potassium dichromate. Diachromate, no. Dichromate. And don't worry about getting these wrong right away, because these take practice. Like, it's not like the super easiest thing to do. Okay, yes, next one is ionic as well. This is iron 3 nitrate trihydrate. Very nice job there, Lamanda. This is selenium tetrabromide. And this is pentaphosphorus heck was non-oxide. Yeah, very nice. Okay, that looks great. Like I said, you may want to start taking a look at that homework. There will be one more section left. I'll put that now, so we can do it tomorrow. Remember, I am going to be streaming tomorrow. We have avoided a particular ion so far. H+, that's the trickiest of all the ions. We're going to see it does different things in different situations, but that is going to be one we'll talk about tomorrow. And so you'll see a couple that will have that H+. For now, I would ignore those until we learn how to name them properly. Okay, so with that, as always, drop your questions in Discord. If you have any, go ahead and start taking a look at the homework and have fun. So it's called nomenclature, by the way. That's the latest one. This means naming. So, okie doke. See you guys tomorrow.